Uh, Hello friends, welcome back to my YouTube channel Infinite Knowledge, and I am back with another great MATLAB simulation based project. You can consider this project for the your BTech project or for your MTech project as well. For mini project also you can consider it. So what it is the grid synchronization, or you can say generator synchronization. So what is the synchronization? So whenever if you consider a power plant, you in power plant there is a different generators are there, and that generator must be synchronized with the existing grid. If you don't synchronize with the existing grid, then it will cause a circulating current through the generator winding, and that may cause overheating and sometimes may cause the direction, or you can say it's come out from this winding, so that totally damage the internal winding of the generator. And that's why the synchronization is very important in the substation, and that synchronization can be checked by these four important values that I have developed. So what I will do, this is the main generator, this is a reference generator, and this is the grid, and this is a generator that generate that start. We have initialized this generator in the power station, and we need to synchronize this generator with this existing grid. So how we can do, the simulation will explain. So what the simulation is contained, so this is the synchronization check. These are some values. So what is the values? So first one is the voltage in the range. So the voltage magnitude of the grid and the generator that is recently start must be in the range, must be less than 1 or 2 percentage. So we can consider less than 2 percentage variation in this voltage level, in the voltage magnitude. More than it is not considered, and if it is more than it, then the synchronization will not happen. And this is a final control. All four parameters will check, and the final control generate the output which turn on and turn off this final breaker, whether it will synchronize or not. So first is a voltage magnitude. Voltage must be in the range less than 2 percentage variation is okay, but more than it will cause any issues. Okay. So second one is so first is the voltage which we are taking from voltage from grid and voltage from generator from here, and first one is voltage from grid. So here we are measuring the voltage, and this is the frequency. Here we are measuring the frequency and the angle, and here we are measuring the actual power. Okay. So then second one is our frequency. So frequency must be in the range. It may be in the 0.0 to 0.1 hertz. So 0.1 hertz difference is okay. If it is more than 0.1 hertz, then it is abnormal and it causes the out of synchronism. And we will check if the different frequencies synchronize, then what happens. We will check that one also in the future. So just stay tuned with this video. Then second is voltage angle magnitude. Angle must be same. Okay, generator angle. So we are taking two reference, one from the grid and one another from this generator. And one is phase sequence. Phase sequence must be right. RYB connection must be right. So here I cannot check that one, so I just use this switch whether it is okay or not. You can just turn on and off. If it is turned on, then phase sequence is okay. If it is turned off, then phase sequence is not okay. So yes, I just started the simulation and check whether we are getting output high or not. It takes some time to check different values. So if all the values are in range are okay, then there is some time delay. If it is range, then this we are getting high command, then all the things are okay, and that's why we are getting 1 over here. Okay, 1 means our breaker is started, everything is okay, and it got the synchronization is done. So if you want to check, you can just double click over this block. So it takes some time to stabilize, and if you want, you can check this output also. So yes, this is a power. So initially all the power is taken by the grid, then our this breaker is started, so it's reduced, and half power is divided into two generator. So initially the current is 0.4, estimatedly 0.5. If so, I just turn on the breaker, so we can control it. This is a phase sequence. I just turn off this breaker, which means phase sequence is not okay. If phase sequence is not okay, then this will control output will remain zero. Control output will remain zero means this breaker will not operate, and only this breaker is there. Only the this main grid is there, and which is feeding our load. So you can see 0.52 ampere. 0.52 ampere is feeding by this generator, and this is the power 9985. Now I just turn on, and this generator, this breaker is off. That's why current is zero, and power is also zero. Reactive power is also zero. I just turn on this switch means phase sequence is okay, and then finally we can start our breaker. Okay, the breaker is start. You can see the power is reduced. Why it is reduced? Current is also reduced because initially all the current was taken, what was feeding by this generator, but right now this generator also come to the picture. This breaker is on, so load is divided into both generator at 0.26, 0.26, and we are getting finally this much amount of ampere. So yes, if you clearly wanted to see how the active and reactive power change from the grid generator, you can check this one. So yes, initially all the power is taken by this generator. This is zero. This is also zero because this generator was not in the line. Only take power taken by the load from the grid, and this is active and reactive power. But once it started, the active power is also reduced, and the active power is also reduced, and this increase from 0 to 5000, and this is also increased from 0 to 500. Okay, so all the load is divided completely between the generator and the grid. But if the this is only happen when the synchronization is okay, voltage is range, frequency it is range, angle it is range. Right now let's consider we have synchronized with the different frequency, like this generator is a 60 hertz and our main generator is on the 50 hertz. You can see this is our 50 hertz generator. So what happened right now? So I have provided this manual switches, so I can manually turn on this switch. So I just start the simulation and check whether synchronization is okay or not. So right now frequency is high. We are getting 60 hertz. It means the frequency is very high. So it takes some time to measure. So initially it measures the 50 hertz, but after some times we are getting the okay. So this is happened due to we have set our range, and that's why we are not getting exact output. So for that, what we have to do, we can set this frequency to the 60. Okay, and I have start the simulation. You can see 60 hertz is there. So if the 60 hertz is there, it means frequency is not synchronized. We are getting zero, and that's why the output is zero, and that's why the synchronization is not happening. But if I manually synchronize, this is a manual switch. I want to synchronize 50 hertz with the 60 hertz and check the consequences what is happening. Then I just turn on this switch. So I just started this switch, and right now both the breakers are on, and check what is happening. I have to wait for some times because we have synchronized two different frequency. We have synchronized 50 with the 60, and check what will happen. You can see the current is drastically increased in the both the system, and variation is lots of variation is there. I just stop the simulation and will check what is happen. So I have synchronized two different frequency. You can see variation is there. I have synchronized the current spike is very high. Initially current was nearly 0.2 ampere, which increased to drastic to 1000 ampere, and voltage is also reduced. You can see at this point we have start the breaker, and voltage is also reduced, and current is also spike. Current is also increased, voltage is reduced. So same over here. So if you want, we can do for more time. If you do it for more time, you will clearly see how the variation are there. We need to wait for some time. So right now also two frequency are synchronized, two different frequency are synchronized, are going to synchronize. One is from the grid. From the grid it is 50. From the new generator that to be synchronized it on the 60. So different frequencies there, and checking which type of variation that we are getting over here. So you can see how the voltage and current are changing. You can see it is going in the oscillation. This is a current spike. Initially current was 0.2 or 0.5 as per the load requirement, and right now current is very much high. So this is what happen if you synchronize two different frequencies. And yes, our load is also getting this much amount of voltage and current. So definitely it is not recommended to synchronize the different frequency, and this is the reason why we have to maintain the frequency in the power station. So again I just changing whatever I have changed. So right now everything is okay, and this breaker must be in the off condition. And again we are going back to over here and check whether our frequency it is range or not. Right now everything is okay. If everything is okay, then we are getting high command, and after some time I have provided this delay for unnecessary start stop, and we are getting high. So our breaker are synchronized properly, and again we are getting satisfactory voltages, satisfactory current, and satisfactory voltage waveforms. Okay, so it is clear. So initially this breaker was on, that's why high current is taken, and at some times the generator 2 come to the line, and that's why current is reduced, and after some time everything is very much stable. And if you want, you can check this. Initially all the load taken by this active power was taken by the grid. The active power is also taken by the grid, but at this condition we have start the another generator, new generator, and right now new generator come to the picture, taking some power, taking some reactive power, and that cause reduction in the grid input. And this is how we can synchronize the generator with the grid, and how satisfactory it is working. And these are the parameters that we have to check whenever we have to synchronize any generator with the grid in the power station. Thank you. Thank you very much. Thank you for watching this video. If you want this simulation file, that is available in the description box, you can connect with me through my email ID that is given in the description box. And if you want any type of MATLAB project, any type of electronics, electrical project, you can connect with me, same ID, same email ID. Thank you. Thank you for watching this video. Don't forget to like and subscribe my channel Infinite Knowledge. Again, thank you. Thank you very much.